Hi everyone, this is Germinal Van, and today we're going to talk about the application of integral calculus in economic analysis. As you see, I have my notes because I'm going to walk you through the process. But before I start, let me tell you a little bit why I decided to make this video specifically on the use of integral calculus. So integral calculus is used in economics, but the thing is that it's not used extensively. In fact, what is mainly used in economics and the basic tool is differential calculus. Differential calculus is used to analyze the supply and demand curves and how they're related to price. So in order to use differential calculus, you need to know and you need to understand and know the rules and properties of derivatives, because that's all it's about. So you need to know the power rule, the addition and subtraction rule. You need to know the quotient rule, the chain rule, and all these, or implicit differentiation, all of that. Because in order to use integral calculus, you must know the rules and properties of derivatives. In fact, you cannot do integral calculus without knowing derivatives, because integral calculus is simply the inverse of derivatives, the same way the exponential function is the inverse of the natural log. So if you understand that a little bit, then that should be fine. So here what I'm going to talk specifically is how to use integral calculus in economic analysis. In fact, in economic analysis, integral calculus is mainly used to understand and analyze cost theory. So in this video, I'm going to walk you through three aspects where we can use integral calculus. These three aspects are not exhaustive. In fact, they're not the only aspects where integral calculus is used. It is also used in macroeconomics, but here it's going to focus on microeconomics. So the first will focus on marginal revenue. Okay. So I'm going to focus on marginal revenue for a second. So what is marginal revenue? It is simply, the reason why I start with marginal revenue is because marginal revenue is the derivative of total revenue. Okay, which is known as TR. So marginal revenue is a derivative of total revenue. So in order to calculate total revenue, you need to know what the marginal revenue is. And we know that the formula for marginal revenue is known as MR equals change in TR over change in Q, which is equal to, I'm going to write here for you, change in total revenue over change in quantity. All right. So this is for the marginal revenue. This is if you know that you already have the values for total revenue. But in this case, you do not have the values of total revenue. So that's what you're trying to determine. In the case we're going to apply, you do not have the values of total revenue, but you have the values of marginal revenue. So the formula for total revenue is, so TR equals, okay, Q0 over 0 of MR QDQ. Okay, so the integral here in fact represent the recovery. So okay, you recover So recover the cost of marginal revenue. basically. That's what it's about. So the integral here, it's simply the recovery of the cost of marginal revenue. So let me show you a brief example. Let me show you the application of an example of that, right? So I'm going to move a little bit here so you will see. So let us say that the marginal revenue for output X, so right, the marginal revenue for output X is given by the function MR equals 100 minus 2Q minus Q squared. And we're asking you to calculate the total revenue. So you know that total revenue is the integration of the marginal revenue. So you're simply going to apply, so you're going to put TR equals Q0 over 0. But here I'm not going to compute. Okay, I'm not going to compute the Q0 and 0. I'm just going to calculate. I'm just going to simply determine the function itself without computing the values of Q0 and Q. So it's integration of Q0 over Q of 100 minus 2Q minus Q squared dQ. Alright, so you're going to put TR equals. Now when you apply, the integration is going to give you 100Q minus 2Q squared over 2 minus Q cubed over 3 plus C. Okay? Why this thing is going down like this? Okay, 1 second. Minus 2Q squared over 2 minus Q3 3 plus C. Okay, this is the function. Of course, you can try to simplify by simply suppressing the 2 here. So it's going to leave you with TR equals simply 100Q minus Q squared minus Q cubed over 3 plus C. Alright, so a brief revision for those who may have forgotten. So as I said, integral is simply the antiderivative. Is simply the antiderivative of the derivative. So you know that here, so the integral of x is going to be x n plus 1 over 1 plus 1. So here, if we take the q, right, the q here, let's ignore the 2, let's just take the q. So it gives you, we assume that the q, if you see nothing, it means that it's power 1. So q1, q power 1 plus 1 over 1 plus 1. So it's going to give you 2q over 2. The reason why we have 2q is because we have a 2, so we simply simplified. But originally it is this, right? So, and then the same goes for q3 over 3. So this is a brief revision, but that's how you do. So if we ask you to calculate the function of total revenue, that's how it is. You simply apply this. All right. Okay, so now we're going to move to the second one that I want to show you. It's about consumer surplus. Okay. Consumer surplus. So consumer surplus is simply the difference. So let me write here, consumer surplus is the difference between consumer willingness to pay and, let me put the N in red, and the actual amount that the consumer is paying for the good and service. And the actual amount that the consumer is paying for the good and services. Okay, so that's consumer surplus. It's the difference between the what consumers are willing to pay and the actual amount that consumers are paying for what they're consuming. And the formula for that is simply, so we're gonna write here CS equals integration of Q over 0 of GQ minus P0P. All right, so that's the formula for consumer surplus. So it's basically is the quantity demanded, what the consumer wants, minus what the consumer is actually paying for. All right, so let me show you another example here. Let's apply. I love integration, they're fun. All right, let's apply this, right? Let's say let us say that the demand for a good is given by the function okay, we know that it's going to be P equals minus Q plus 20. Okay, so that's the demand, or if you want I can put D so you will know. Let me put D because we say here is DQ. All right, and then we know that let's say what the consumer is consuming right now. So let's say that P0 and Q0, right? So let's say P0 is $10 and Q0 is $10. So the consumer is consuming actually $10. Therefore, the quantity they're consuming is for $10. All right. So let us write this function here. So consumer surplus is going to be, integration of minus Q plus 20 GQ minus 10 times 10. Remember, P0 times Q0. So remember, it's the actual P0 is the actual amount that the consumer is paying for the good and services, and Q0 is the quantity that the consumer is currently consuming. All right, so it's going to give you, so if you want, what you can do is to simply rewrite this again. Minus 100. Okay, or if you want, let's, yeah, okay, we have this, right? Minus 100. So CS equals simple as that. That is the function. That's the demand. That's the demand function for consumer surplus. Okay, it's the demand function for consumer surplus right here. Simple as that. And now I'm going to show you the last one, which is producer surplus. All right. All right, producer surplus. Producers surplus. All right. So producer surplus is simply the difference between what the producer is willing to receive to produce a good and the actual amount received. Okay, so it's the difference between what the producer is willing to receive to supply, so to increase its supply, to increase, so to receive the supply of a good and the actual amount received. Okay, so this is pretty straightforward, and the formula for that looks like a integration by part. So it's going to be P0 Q0 minus right, so this looks like integration by part, but this function can be also written as this. All right, so now let's show you guys an example of this. So let us say we want to know the producer surplus, and we know that, so basically let's determine the function, right, for the supply function. So we know that P0 equals 8, Q0 equals 40. Let me rewrite this 8, it looks weird. All right, and we have the supply function, which is 3 plus 2 minus q plus 30. All right, so you simply doing this. So p0 times q0 minus s, the supply function. All right, so it's going to be 8 times 40 minus integration of 3q square, q plus 2q square minus q plus 30 dq. All right, this is going to give you 320 minus integration of 3 plus q minus q plus. Okay, so what is it going to give us? Minus 3 4 plus 2 plus and you have your function here. So I can even write it here again. So PS is going to equal to 320 minus 3q to the fourth power over 4 plus, right, 2q to the third power over 3 plus q squared to the q squared over 2 plus 3q plus c. This is the producer surplus function. Okay guys, so this was just to show you a little bit how integral calculus is applicable to economic analysis and to economic theory in general. I mainly focus on cost theory, but as I said, it is also applied in macroeconomics, specifically with the Hickson monetary model, when he compares, I can't remember if he's comparing interest rates and inflation, but he used integral calculus to determine that. But here I focus mainly on cost theory because it is the very basic aspect of economics where integral calculus is used. So let me know in the comment what you think, and until then, see you guys soon.